In order to add or subtract two fractions, we need to have a common denominator. And so we've taken a look at in the past videos how to do it when we do have a common denominator. It was very easy. And then in our last video we took a look at how to find a least common denominator. So in this video we're going to take a look at how to actually go about adding them together. Our first two steps are actually what we've done in the previous video. Factor denominators. In this case there's nothing to factor, or we could argue that they've already been factored. It's 4 times x and then the 7 is by itself. So let's build our LCD as we did in our previous video. So we began with finding the least common denominator of the coefficients. In this case there's a 4 and a 7. The smallest multiple that 4 and 7 both have in common is a 28. We then also had to include any variables that we saw, or chunks if they were in parentheses, and the highest power of those variables if there was more than one of them. So in this case the only variable I have is an x. So 28x is going to be my least common denominator. Hopefully you were able to do that without me explaining it to you if you watched the last video. So now we're on to our new part. If you watched the last video, we talked about using the LCD, or thinking of it as the perfect bicycle. We want to make sure these denominators that we have, these sort of incomplete bicycles, become this denominator. We want to turn them into that. And so what we're going to do in step 3 is we're going to multiply whatever is missing down here to turn it into this. That's kind of my thinking. And so to turn 4x into 28x, what I need to do is I need to multiply that by 7. 7 times 4x will give me 28x. However, you can't just multiply the bottom by 7, you have to multiply the top by the same thing. The reason I'm allowed to do that is because 7 over 7 is really just a 1, and multiplying a number by 1 does not change anything. So let's go ahead and do that multiplication. And multiplying was easy, just multiply the numerators and denominators together. So I get 21 over 28x. Now a very important question I ask in class is 21 over 28x any different than 3 over 4x? And the answer is no. 1 has just been more simplified. So I've not changed the value of anything, I've just changed what it looks like. Okay? Let's do the same thing with the second fraction. I want to turn the denominator that I have, this incomplete bicycle, into this perfect denominator, this perfect bicycle. And so I think, what do I multiply? What do I multiply 7 by to get 28x? And to do that, I need to multiply by 4x. I multiply the bottom and the top by the same thing, because that's really just multiplying by 1, and that's not changing anything. And so the second fraction becomes 4x, 1 times 4x is of course 4x, over 28x, with that subtraction sign still in between them. And again, a very important question is 4x over 28x any different than 1 over 7? And no, it's not. The reason though that this has got me to a better place is that, look, now I do have a common denominator. And so now what I can do is I can add or subtract the numerators. 21 minus 4x, they're not like terms, so I can't do much with it other than say 21 minus 4x. And then that denominator that we took so long to build and put together, we don't want to change it, that denominator stays the same. It stays 28x. We'd always try to simplify it if we could. Because the numerator cannot be factored, there's no greatest common factor up there, there's nothing to be simplified, so that, after all that work, is going to be my answer for these two fractions added together. Or subtracted, I suppose.